what's up? This is Vex. So this is gonna be a short tutorial on FastSave, which is the runtime saving and loading solution that I've released in VFW134. You can find it under plugins, Vex, runtime, FastSave. There's a README file that I recommend that you go over before using the system. It's not necessary. I'm gonna try to explain what you need for the most part to use the system in this video, but I do recommend that you go over the README file. And there's also a bunch of simple contrived examples under VFW examples, FastSave. So first let me just give you a basic overview of the system, what you can do with it, the public API and stuff like that, and then go over the examples and explain some of the things. So it's a runtime saving and loading solution for game objects and stuff like that. But this is not a generic system that that you could put in almost any game and it works just out of the box. No, this is a saving and loading framework. This is not a like I said, like a solution that works for every game. This is a framework that helps you build the saving and loading system that you need for your game. This is because every game has specific and different requirements for their saving and loading systems. So yeah, you can read or write game objects, components, hierarchy of game objects, and marked game objects, which we'll talk about in a minute. So read or write to or from, stream, so file, memory, or just base stream, stuff like that. Initially it was a separate asset, independent asset. I was planning to sell it, but I changed my mind. I integrated it into VFW. It has a dependency on VFW, not the runtime codes, but just the editor codes, which means you can extract the system out of VFW if you can replicate the editor code that is used for the system, should you ever want to. Or you can just use it without any editor codes. I don't know. It should work on IoT platforms, but I haven't tested it. I think there's a bunch of areas in the code where it will fail right now. Like it gives you JIT exceptions, attempting to JIT compile, stuff like that. But it's nothing that we can't fix. I just haven't tested it yet. I just don't have an IoT device. So what kind of components does it support? There's transform, rigid body 2D, mesh filter, renderers, animator, camera, character controller, and all that good stuff. Assets, asset references, supports mesh, audio clip material, and all that good stuff. System objects, the serializer can serialize 1D arrays. Of course it can serialize custom classes and structs, arrays, lists, stacks, queues, and dictionaries. Polymorphic serialization, how about polymorphic serialization, cycle support, serialization by reference, and string caching. All of these are supported by the serializer if you want to enable. By default they're supported, but if you don't want those things, like in my game I don't use polymorphism, I don't use cycles, I don't need cycle support, I don't need serialized by reference. So there's a mode that you could set for the serializer. There's two modes. There's standard 1 and minimal 0. Now 0 only gives you string caching, and 1 gives you all these things that I mentioned. By default the serializer is set to 1. If you want to change the mode, you say fs common serializer set mode 0. Okay, but for the most part I recommend that you stick with the default mode. If you need a minimal mode you can switch. Basically the difference is between the data layout or the output format layout. The minimal has like a more minimalistic output layout, has a smaller size, basically a more efficient smaller output. This is outdated, I think. Okay, forget about that. So a little bit about the underlying serializer that I'm using. It's a reflection-based serializer. It uses dynamic reflection. It emits basically IL to generate getters and setters for fields and properties for your standalone builds, which means you can get fast reflection for standalone build and regular reflection in other platforms that doesn't support runtime dynamic code generation. Now let's jump over the usage. The public API is pretty simple. You basically have two static classes, save and load. You can say save game object or component or hierarchy or mark to stream or to memory or a file, and load game object component hierarchy mark from stream, memory or file. When you save, you basically provide an instance that you want to save. So you say, so if you want to save, like you have a game object, target is a game object. So you say save game object to memory, and this will give you back a byte array from which you can take the string. So you can say get string. Now get string is an extension method in system. So if you just have using system, you could make use of this handy method here, get string. So you can get the string of the byte array and then save it into player prefs, for example, or something like that. I don't know. And then to load the data back, you just do get string and get the bytes out of there. Just like get string, there's also get bytes, also an extension method in system. And then you say load game object from stream. You give it the data, the byte array. This should be from memory actually. Yep. You give it the byte array and you give it the target that you want to deserialize into. So the target game object that you want to load this data into. If you didn't have a target, you can just say new game object. You know what I mean? Yeah, and there's also like extension methods for the system. So instead of saying save game object to memory, I could have said target save to memory. Okay. So there's a and you can also save system objects. So if you had like a dictionary, you can say save object to memory. Okay. Or if you had a list or something, anything basically. So yeah, let me go over the first example now before we move on. Nope, not that one, that one. Okay, so we have a cube here that we want to save. It has a data script, has a container, which is a dictionary, has a string, an int array, a list, a mesh renderer, a game object in the scene, and a prefab. Let me just lock this inspector over here, and let me assign this renderer. Okay. So, and then we have this test script, which is inspected by this second inspector here. Oops. So we give it a target, and we have an output field. So when we say save go, we just say game object to memory, we give the target, and we get the string from that and store it in output. If you want to load this output into a new game object, we say load game object from memory, give it the output, we get the bytes out of that output, make sure you have using system, and we give it a new game object. Here we're just using the extension method. Like you said, there's a bunch of extension methods you could use. So we say target load game object from memory, output get bytes. This is equivalent to saying game object from memory, output get bytes, target. This is the exact same thing, but it's just a shorter way of saying it. So if we hit save now we're basically saving this cube. So if you hit save, okay, and move it around, change its scale, mess with its box collider, mess with the renderer, material, mess with some of the fields, just in general, mess with anything, set this to null, mess with that, mess with this, yeah, you get the idea. And then when you say load, let's try load into a new game object. So it's gonna create a new game object and load the data that we saved into that. And like you see, the data is back intact. All the references are back, all the data is back, collider, the scale, the position, and all that stuff. And if we load into the target itself, so load this object back, basically, so it goes back. And that's pretty much it. Now, let's just ignore FS reference for a moment here. Now, if you do, if you save a game object, you might be wondering, well, what components are you saving when I save my game object? If you don't have a save marker on your game object, all the components will be saved. Now, a save marker is basically a component that you could add to customize what components you want to save. So if I say fs marker, it gives me a list of the component types I want to save. So let's say I only want to save what? Oh, come on, don't fail on me. Oh, great. Okay, failure. Okay, let's do it that way. Let's just leave out transform. I don't know what that was. Like, it should have. Yeah, it's a bug. Should fix it. So in this case, we're only saving transform. So if we save, mess with the scale, the rotation, the position. Now, if you change the material or anything other than the transform, and then load it back, you see the data that we didn't save basically didn't get loaded back. So we didn't tell it to save the mesh render, so the material stayed red, didn't go back to blue. And this key, this value here, also, I can't remember which one I've changed, but I think this one, yeah, it didn't go back to the value it had before. If we added the material, on the other hand, okay, save, change this, green, load, so it's back to red. The transform's back, but not this data here. So if you have a marker on your game object and you do a save game object to memory, I look up what components you specified in your marker and save those. If you don't have a marker, I save all components. That's basically it. Okay. Yeah, so this is what this marker does. You can read. Now, what if you had a script with basically your data, and And like this script, for example, if you specify that you want to save the script, what fields that do get saved. Now, public fields are saved by default. Non-public fields are saved only if you annotate with save. You can explicitly specify that you don't want to save it by using don't save. Yeah, so that's how you can customize how you want to save your fields via save and don't save. Outer properties are also supported. FS reference. Now, notice in the scene we had a reference to a material, a renderer, an in-game scene, game object, an in-scene game object, and a prefab. Now, if you're saving a script that references a game object in the scene, that game object has to have an FS reference script into it. Okay. You can look up how I implemented this FS reference, but I'm not going to explain it now. But just know that if you're referencing a game object or a component or something in the scene, that referenced game object or component has to have this FS reference. So this is what F reference is. Prefab. How do I handle prefabs? Well, the way I handle prefabs is if you go over the resources folder, there's a prefab storage asset. Basically, you tell it to populate, click populate, and it adds all the prefabs in your project. If you have a big project, you might want to have multiple prefab storages, but I'm just using a single one for now. So it adds all the prefabs in your project. In my case, I only have one. And so what it will do is basically when it comes across this field here and tries to serialize it, it basically does. Let me show you the logic. Why am I speaking? Reflective component serializer. So serialize game object reference. So yeah, whenever the serializer comes across a game object reference, this is what happens. So if it's null, we write 0 and return. Now we check to see if this game object is a prefab. If it is, we just write the ID of that game object, basically the index in the prefabs array of that game object. If it's not, we use this FS reference thing. And then when we load, we check to see the byte that we wrote. So again, if we wrote a prefab, we write 1. So if we read a byte, if it was 0, we return null. If it was 1, we read the prefab ID and get it back from the storage. Okay, basically prefab storage just maintains a list of game object, and when I say get, it returns the prefab at that index. And yeah, that's pretty much it. In-game components are dealt with the same way as in in-game or in-scene game objects. So in this case, this renderer here is basically this one, and since I'm referencing this renderer, this game object has to have an FS reference. Okay. So yeah, this is what we talked about prefab storage. Asset storage is similar to prefab storage. So if you go back to resources, there's an asset storage. This basically saves pretty much all asset types, so meshes, materials, text assets, and pretty much any asset. So in this case, like when I save mesh render has materials, which are assets. So we have to serialize those materials. The way we do that is just by storing them in this asset storage, just like we did with prefab storage. So when the serializer comes across a material, it just adds it to this list here. I might have to cut the video and do another part. Okay, so see you in part 2. Sorry about that.